Welcome, everybody, to Stay Curious. I'm your host, Mark Marquette, and beside me is what we call a real national treasure. No kidding, Maynette Smith. You didn't know you were a
You.
national treasure, did you?
Thank you.
Well, that's what we call our space workers, whether they're Apollo era or Shuttle era. And we've been doing this for over uh, 5 years on our program. By the way, I'm your host, Mark Marquette, and so glad that Maynette's here with us today as we want you all to stay curious. And we're going to talk about her life and times as a NASA employee. And yes, we call them national treasures because you all did two things that no other country's done: put people on the moon and build an international space station for over 25 years has been a true outpost for humanity orbiting the Earth. And Maynette had a lot she was involved with it. I always say you all have a lot to do with stuff, but you were part of a good team.
A big team, yeah.
And it takes all the links of a chain to make it strong. And you're going to hear about a couple links that she was involved in. So, Maynette, great to have you here.
Thank you.
Thank you so much. We're going to hear a little bit about you here in a minute. But first, we want to, well, let's go backwards here then. All right, we're going through your slideshow real quick here to get, oh, we were just one off, I guess. It's her journey with NASA, okay. But we want to let you know that we got Bob Seek. Will be our next Legends of NASA dinner at the Italian American Club. We're going to do it November 12th, Wednesday. Okay, from 6 to 9, dropping the price to $40 a person. We made some good money at 50 with Mr. J. Honeycutt, but we understand times are a little bit pinching pennies for all of us. So talk to Bob today. He's excited to present a program, a nice informal dinner. If you're local, you're not going to want to miss it. This is one of the true architects of the shuttle, as you well know.
Mm-hmm.
Where would we have been without Bob's leadership?
He's amazing.
Yeah.
Really amazing.
And did you ever report to him in any of your duties or?
Not directly though. I got to see his great work.
Yeah. All right. Well, you'll get to hear about his great work there. Bob Seek launched, he was a great shuttle manager, which was putting all the pieces together after Challenger. And Jay Honeycutt had a hand in that too. And then Bob launched 51 shuttles. All right, of the 135 as the launch director. So his insight is just incredible. And we also want to thank everybody, including you, Maynette, for your generous contribution to help the American Space Museum rebuild after our small kitchen fire. We did a GoFundMe on there for it, and hope that you all follow our lead and donate what you can, from $20 to 100 or whatever. It's mostly to defray our cost of $2,000 deductible and some incidentals, of course, that won't be covered. So you are donating, and we appreciate that. Well, your journey with NASA, Maynette Smith here. Let me just welcome RG Jubilees on there and Dave Stange as usual. We'll have the usual suspects. And if you got a question for Maynette, what's it like to be a space worker? Anything is fair game, I'm sure. But first off, we always like asking, where'd you grow up? What was your family like? How'd you get involved in the space business, Maynette?
Okay. Well, I was born and raised in Louisville, Kentucky, and my father was an engineer and got me interested in all things science and math. In fact, he worked for a company, I can't remember if it was Anaconda Aluminum or Reynolds Metals, and his name is on a uh, patent that was used on the lunar excursion module. It was some metal that was used on the
Oh,
lunar
really? What's your
excursion
dad's
module.
name?
Addison Smith.
Addison Smith.
Yes.
That's a bunch of Smiths with some interesting first names.
Yes.
Because Maynette's beautiful.
Well, thank
But
you.
you're the only Maynette I've ever met.
Well,
I've
my
noticed
mom's my mom was Maynette, so
Uh-huh.
that's how I got named Maynette.
And Addison.
So,
All right. It's very good. And
yeah.
Louisville, Kentucky. Did they celebrate Muhammad Ali a lot? That was his hometown.
Oh yeah, yeah, very much so. In fact, he is buried in Cave Hill Cemetery right
Uh-huh.
there in Louisville.
He did some nice things for the
He
city
really
over his
did.
career.
He really did.
Yeah, awesome. You and I grew up with that sort of
Yeah.
Ollie Frazier fights and all
Oh
that
yeah.
stuff in there.
Oh
Well,
yeah.
I did. You were told about them, but
Well,
you
I
made
would,
it.
he's what, float like a butterfly, sting like a bee,
That's
that
right.
kind of thing.
Yeah.
Yeah.
Uh, yes, actually, things that are applied in the space business: steady pressure, keep your goals high,
Mhm.
don't let defeat get you down.
Right.
That's part of a lot of things in life. I noticed you went to Vanderbilt,
I did.
Nashville there.
I did. So I kept moving south as I went. I went to school at Vanderbilt, graduated with an electrical engineering degree, got a job with NASA right out of school.
Did you ever go to the Pantheon they recreated there with
Yes.
Athena? Oh,
Yes.
isn't that
It's
cool?
very cool. And
Yeah,
it was right near the school, so we spent a lot of time in that park
yeah.
where the Pantheon is.
Well, I
Yeah.
spent
Or
35
Parthenon.
years in Upper East Tennessee, the Tri-Cities area, Bristol, Kingsport, and Johnson City, and Nashville's always an awesome city to visit. Every time I go there, I have a lot of fun, and I go to see the Parthenon they recreated
Yeah,
there.
it's beautiful.
So, what led you to NASA?
Well, I have always loved space. I love science fiction. Of course, thanks to my dad, I was interested in science and math. And since I was always interested in space, I always had a special place in my heart for NASA. When I was 8 years old, my dad and I watched Neil Armstrong set foot on the moon, and that really kind of set my goals there, as well as watching 2001: A Space Odyssey and seeing what space could really be.
Uh-huh.
So when NASA was interviewing at Vanderbilt, I was like, I'm there. That's where I want to be.
Excellent. And you made it in 1983. I left my notes over there. I don't even need them on you. But in 1983, you started working at NASA. And
Yeah.
what was your first shuttle mission?
Well, when I got there, June 13th, 1983 is my first day of work. STS-7 flew that weekend afterwards. It wasn't, I just watched. I wasn't working it, of course, but it was Sally Ride's first mission.
Wow.
My first mission that I worked was
How'd you feel about
STS-14.
that as a woman and everything that she represented?
Very proud, very proud. It was a great milestone for all of us.
Mm-hmm. Did you ever get a chance to meet her?
I did. She actually, I was working on an experiment that was flying on the shuttle on STS-41G, and she was one of the mission specialists and came down for the testing.
Uh-huh.
So I did get to meet
I
her.
understand she's pretty humble demeanor and
Very quiet, very, very unassuming, just really an amazing person.
really a petite lady too, wasn't she?
Yes, very much
Yeah,
so.
we had a polo shirt of hers. It was I showed ladies this is size medium, and it would look like it fit an 8-year-old.
Yeah,
It
she was very petite. When I met her, I'm like,
Sizes
and
have changed
I'm not a
since
big
then, but
person, but she was very petite.
yeah. Well, that's nice. We honor her. Of course, we were the only place in the world we think we have her handprints there in our women's
very cool.
gallery. So
Very cool.
that's in there. Well, Maynette, I'm gonna we have Elena Adhikera is there from South Africa, and Tom Usiak. Good afternoon to you, Tommy. We've got Rosalie there, and and we all want to be thinking about Cliff Watson, our regular friend there. He got some bad medical news, and we want to note your our thoughts and prayers, Cliffy. He'll be joining here in a little bit. But Maynette, let's tell me when to advance, and we'll go through your little
Okay.
program here.
Okay. Well, this a little bit of background. This presentation I gave to some students from Japan just a few weeks ago. So you'll see some of this is geared more toward the students, but it kind of tells a little bit about my experiences.
Well, we're all students of the
We're all
shuttle at this
students.
point
That is
here,
true.
and like I said, you all have some good questions there. Let me know. There's Carlton Bailey saying hi to Maynette. His dad went to Vanderbilt Medical
Hey,
School.
nice.
So he says, "Go Commodores." That's right. And so that's who am I?
So, as we already talked about, I worked for NASA. I worked here at Kennedy Space Center for 33 years, from 1983 to 2016, in a number of different capacities, which I'll talk about. These are just some pictures from different parts of my career. which I'll go into. So let's go ahead and forward
Okay.
here. Um, Part of I kind of segue over here. In my retirement, I
Well,
still have ties.
tell us about the
Okay,
pictures.
okay,
Everybody's curious. That's a picture of you at the console there in the
okay.
middle.
Well, they're pictures later on too, but I can talk them
Oh,
here too.
okay.
Um, the one up at the top, that is me supporting the last shuttle mission, STS-135, from the firing room to the manager's firing room, in my role as the division chief of the space station safety and mission assurance group.
Okay.
The one on the top right is an early picture of me with some other engineers. We were troubleshooting using a system called the Payload Integration Test Set, and we were testing some experiments on OST-1, which flew on STS-41D. And in fact, it was the solar array experiment, which you can see a picture of it right down below. That was a prototype for the current solar arrays you see on the International Space Station today. And the middle picture is just showing the space station processing facility. I worked the space station program for a number of years, and that was a time when it was really full with a lot of different space station elements, including Kibo and the Columbus module are in that picture as well.
I remember I looked out the windows at the top on the right-hand side as a tourist. You could actually look down there and see you all working down there. And I
Yeah,
remember Columbus being there.
yeah.
And then after 9/11, they quit that. But did you ever look up and see people looking down at
Oh
you?
yeah. Oh yeah. They it was really it was you kind of felt kind of special. It's like everybody's looking at me
Oh,
doing
okay.
stuff. But
Not like you're in some lab experiment
no,
being
no,
played with
no,
by
no, no,
some
no, no,
evil
no.
scientists
It's
up
like
there.
those people in that. No.
Yeah.
It was really cool, and it was very you really got the international feel because you walked into the high bay and here's the Italians are working on their multi-purpose logistics module. The Europeans, space agency folks are working on their Columbus module. You had the Japanese working on their module, and
Hmm.
it was truly it, it was international in every respect of the word. But it was really cool walking through there because you really got that feel for it.
That made it interesting at the cafeteria, I'll bet.
It did, and they had different signage up there for the different
Did
folks.
they
So
really?
yeah,
Okay.
so
Not everyone had to comply to the English menu or something,
well,
right?
not in the
The
cafeteria,
food.
but in the high bay, they
Okay.
had certain signage for like the Japanese in their area and stuff. So
Great. And then, of course, we see in
that's
the orbiter there
yeah,
brought
that was
back.
when they were starting to decommission the orbiter, so I got to get a
Oh,
picture
okay. All
there.
right.
So
Astro.
segueing a little bit, I talked with the students and telling folks a little bit about what I do in retirement. One of the things I'm involved in, along with our friend Mikey Haddad and Scott Vongen, is the Astro Restoration Project. And you all have been here at ASM, have been great supporters of it. Astro flew on STS-35 and STS-67 and is celebrating its 30th and 35th anniversaries of their missions, respectively. And we have been working at the U.S. Space and Rocket Center to refurbish and renovate and reintegrate Astro as a unit. And you can see the picture in the middle there is the exhibit as it currently stands at the U.S. Space and Rocket Center with some of the hardware reintegrated. On the picture, you can see the on-orbit picture of Astro during its mission.
Of our heads.
And Astro, just as a segue, was a group of ultraviolet telescopes. So they looked at the ultraviolet spectrum. And they initially were going to launch in 1986, right after Challenger. And of course, Challenger happened, and they got remanifested and didn't fly until 1990 and 1995. So
I'm an astronomer. Everybody knows that, and we had these dedicated missions to just telescopes taking them above the Earth's atmosphere, where they could do things that they couldn't because the Earth's atmosphere interfered with some of the data. 3 colleges, universities were involved with this, uh, and they were actually hoping to do maybe up to 6 missions, I think, was at
That's
one
right.
time.
Yeah, they initially it was manifested for 6. They were then planning to do 3, and unfortunately, Astro 3 got
Hmm.
demanifested.
Or
But
Scott Vongen would have been the astronaut on that.
yes, he would have been the payload specialist on that mission. And but we've been involved, Scott, and a whole group of folks that worked at Astro from all aspects of the Astro mission, from the flight crew to the ops folks, development folks, are working to put this payload back together and refurbish it. And we've worked with the University of Florida. You can see a group of those folks up in the one corner where we have been working with or have worked in the past with their mechanical design classes.
Hmm.
And so they actually do some real world design work. We were looking to make a display stand for the Astro cruciform so it could be displayed. And they did designs, 1/5 scale designs of display stands for us. So it was great working with the kids because you can see what talent they've got
Okay.
and really applying it to a real world problem.
Well, this was part of our Shuttle Fest 3 program, I believe, and J.D. Bartow, astronaut, was involved
Right.
in that. And, I can't think about the Astro space shuttle missions without thinking of the late Sam Durant's. And
Yes.
Sam was a good friend of our museum, and did some was always there at some as an astronaut at some of our events. And
Yeah.
he passed away, gosh, probably a little over a year ago. His
Yeah.
birthday was this week too.
Yeah.
He had his birthday. But
He's
say something about Sam. He was a
oh
exceptional man,
he
wasn't
was really a wonderful man, very down to earth, very giving. Really, he was really engaged with students.
he? Mm-hmm.
After his career, as a payload specialist, he came and he worked at FIT, and he worked with a number of students there and who carry on his legacy. And we are hoping to carry on his legacy through this because he's such a big part of Astro and its missions.
Yes, indeed. And we'll have Mikey come on and talk more about this renovation. I saw they actually, Scott did a program at the International Space Development Conference in June in Orlando and gave the presentation. The display is in the middle there. I love it. I love
They've
the
done it.
banners hanging from the ceiling up there. It just really looks classy. They devoted a lot of space to it, it
They
looks
really
like.
have, and they have been the U.S.
In
benchmark,
Huntsville, this is at the U.S. Space and Rocket Center in Huntsville.
and they've been wonderful partners and very supportive of us through this whole thing.
Yeah, yeah. I see Cliff Watson's joined us. Hello, mate, down in Pomona, Australia. I shared just a little bit ago that Cliff's got a medical condition that you can go to his Facebook and hear about it. But we're with you, Cliffy, and stay strong and God bless you. And I talked to you on the phone yesterday. He called me from Australia, and thank you for the heads up there at our astronomy club meeting last night. So Cliff's actually sat in this chair 3 or 4 times
Oh, very
and done a
cool.
program. He came to America at both total eclipses and
Oh,
befriended
nice.
myself in the museum. So hang in there, Cliffy. We're thinking about you, buddy. All right.
So, so this is kind of again more for the kids, but as I mentioned, my dad, who I think the world of and is my hero, is he was an engineer, electrical and mechanical, and he got me interested in science and math. Of course, I studied really hard. I love a good problem. Um,
You love a good problem.
I love
All
a good
right.
problem. I love to solve a good problem.
You're not
Um,
one of those that I can give you a wad of change and you sit there and
no, no,
take
no,
it
no.
all apart in there.
No, I
Okay.
like a good, computer problem or a good,
Okay.
good mystery, something
Not
like
a
that.
puzzle
I'm
problem.
not, I do Wordle. That's about as far as I do.
Okay,
Yeah, so
Wordle. I
yeah,
did Wordle for a while.
yeah, it's pretty. I do it with the family, but so as I mentioned, my dad and I watched Neil Armstrong set foot on the moon.
Uh,
First time I ever came down to Kennedy Space Center, I saw the Saturn 1B sitting on the milk stool for the Apollo-Soyuz mission.
Oh my.
So, and that's the picture
Yeah,
down at
that's
the
the
bottom.
picture. I got it. Are there other siblings in your family or?
I've got one younger sister,
Okay.
and we all came down, and so it was our first visit here,
All
and
right.
it really resonated with me. In fact, that was the time when they took the buses in the VAB for the tour and all
Now,
that kind of thing.
incredibly, Tommy Usiak was there. You know, Tom,
Yeah.
you met Tom. Tom, that was, he was a photographer from Apollo 15
Okay.
on up as a college student
Oh wow.
from Pennsylvania. So he actually was also there and photographing that. That might be his picture
Could be. It
somewhere
could
in
be.
there. So,
But it definitely resonated with me, and got me interested in pursuing engineering, and particularly with NASA.
hmm and then let's see, you got your so you're a Trekkie
I'm a Trekkie.
over Star Wars. Okay.
Yeah, well, I like Star Wars, but I'm kind of a Trekkie over
Good,
Star
good.
Wars.
And as you say there in the smaller one, she watched the moon landing with your dad there, and my gosh, it's unbelievable that we've not been back, quite frankly.
I
But
know.
I thought we'd have like Antarctica bases,
Oh, I
where
figure,
30 people were
I
living
was
there at a
thinking of
time.
2001: A Space
Yeah,
Odyssey with, you can take trips
yeah.
to the moon and
Well, if they'd
all
just
that.
given von Braun a blank check, he'd have been on Mars by
Oh,
1985.
he had the
He said,
plan.
yeah,
He had the plan.
absolutely. So, all right, data systems and experiment test engineer.
Yeah, so when I got hired into NASA, I was hired into a group known as Level 4 Experiment Integration, which was,
Level 4. All right.
yes, this was a group, it was on the payload side of the house, pretty much the horizontally processed payloads that that went into the payload bay. And they had a group of NASA civil servants. It was a training ground for them to learn how to do hands-on work so they could move on to other positions and be informed, well-rounded engineers. And so I worked in the electrical side of the house, and I worked in really two different ways. First, as a data systems person, we had several data systems that process data for either Space Lab or the partial payloads, and we processed that data and gave it to the experimenters so they could look to make sure that their payloads were functioning well. And then for also some command and systems as well. And in addition to doing that kind of work in the background, we were also assigned different experiments to test their compatibility with these shuttle systems before we actually got them into the shuttle.
Mm-hmm.
And so I worked on three main payloads during that time frame. One was the solar ray experiment and dynamic augmentation experiment, also known as SAEDA, which was flown on STS-41D. And again, the solar ray experiment was a prototype for what we currently see today on the International Space Station.
That was a huge deal, though. That had to work right, or the space station would.
Yeah, so
not.
this was 1984, 85 time frame.
Mm-hmm.
So they were testing the deployable mast structure. They wanted to see how the flexion of once they had deployed it out. So they were looking at the motion of it. They were looking at the mechanical structure. They did have a few active solar panels on there, but mostly it was dummy panels because they were looking at just the structure and how it operated. The dynamic augmentation experiment was a laser system that helped measure the flexion on that.
Mm-hmm.
And that particular mission was the one that Judy Resnick was on. And I got to meet her and work with her closely.
Okay.
And she was the mission specialist that was responsible for operating SAE and DA. And I actually, when I was first coming out as an engineer, they flew us out to Lockheed Martin Sunnyvale, who had built this, and they had it in a zero-G fixture so they could deploy it out. And she and the crew were coming to look at it as well. And a little side story, I'm standing there, all dressed up, and my first really big trip, and couple journalists come by and they go, "Hey, are you Judy Resnick?" And I'm like, no, but I want to be, And we both had long dark hair at the time, um, so I was very flattered. But no, I wasn't Judy Resnick. But she actually came down for our testing. She called me out with questions. She treated this newbie engineer out of school like one of the team,
Huh.
and just very supportive, wonderful woman to work
Oh,
with, and a real loss,
yeah. Yeah, she
tragically.
was some smart lady.
She was.
And I mean, she was being uh, trained as a teenager to go to school at Juilliard in piano or something
Right,
like that. She ended
right.
to go in the engineering school,
Carnegie Mellon. No,
Mel, uh, I want to say Melanon.
I'm
That's
running a blank myself,
yeah, yeah.
but yeah. Well,
No, no, she
and
could have been anything she wanted to be. She aced. She got a perfect score. Judy Resnick did on her high school ACT test. A perfect score, like the sixth woman ever to do that.
yeah, and she worked
Imagine.
for the National Institutes of Health. She was biomedical engineering,
Wow.
and just
But she
very.
wasn't big time in anybody, huh? You said she just.
She was very. I was a little in awe, and she was just like, hey, she called me up and she goes, hey, the crew's down here, and give us a tour of the ONC high bay, and I'm
No.
like, okay, you probably know it better than I do, but yeah.
Judy Resnick.
So she was amazing, and really the first crew member I really worked with.
Well, we love these type of stories, okay? And what comes to mind is you're talking about integrating, the experiments and so forth in the payload bay. And it struck me as an analogy here. Michael Bruno's asking, what is the highest volts that existed in the shuttle? Before you answer that, I'm imagining it's like everybody's kitchen. There's the microwave, there's the toaster oven, there's the can opener, and you can't run the microwave and the toaster oven at the same time because they may blow a fuse,
The
right?
fuse,
Is this the
yeah.
kind of things that you were doing to see what would handle
Well,
loads, and what was the highest voltage, if you know?
well, there was
Yeah, am I right? Was that an interesting analogy or not?
that it
Refine
is
that for me.
what they, of course, I've never known them to blow any circuits on the shuttle. Our testing was pretty much we would do um, continuity and measure checks on the lines to make sure that we had no issues with the wiring. But then we actually functionally operated the experiment to make sure that the commands and the data and everything, the timing on everything was right. There were no grounding issues, this kind
Hmm.
of thing. So, because all these experimenters are building experiments based on a book called the Interface Control Document, and
Interface control
or
document.
the
The
ICD.
ICD. Okay.
And and yeah, it's pretty explicit, but even then you would find that interpretation is different. Timing may have been a little off on some of the commands or the data. Um, it was a process to make sure that everything really worked before we actually put it in the shuttle. And then we would do the interface test in the shuttle, and then they'd be ready to fly. As to the maximum voltage in the shuttle that they have, I assume they mean your operating voltage. A lot of stuff was operating at 20 volts DC, a lot of stuff, but I wasn't a power person, so I can't really go into but I know that, I'm sure they had, you know, ways to ensure they weren't going to, blow a fuse or something like
Hmm.
that.
Great. Also, is of interest is all of this equipment is made to work in 0G, not in 1G of
Yes,
Earth.
and that
So
makes
the
it
wires
hard.
can be thinner and stuff like that, right? For
Well,
weight or what?
you've got certain mill standards that you always live to in terms of, but you've got flight qualified, certain types of Amphenol connectors, things like that that they build with. Um, what is harder in a 1G environment, and the solar array experiment was a prime example of it, is you could not deploy the mast beyond 12 inches in a 1G environment or it would collapse because it's built for a 0G environment.
Okay.
So that's the reason we
You're
had,
talking about the panel
yes,
there in the upper left-hand
upper
corner.
left-hand corner. That that's the reason they would hang it sideways, and they had weights, and they had a 0G fixture at Lockheed Martin Sunnyvale that
Okay,
they
to
would
simulate that.
to simulate that. So when we actually did testing, we actuated it. We wanted to actuate a command to start the deployment, but we had to shut it down really fast because we couldn't let it go beyond 12 inches deploying because we didn't want to break it. And we had this with a number of experiments where, you know, they're built for a microgravity environment and you have to find workarounds to test the hardware.
How'd that work out on, what was that,
41D.
41D, looking at my shuttle scroll
And
here.
it worked great. Of course, we had a couple delays on 41D. 41D was the first mission that they had a main engine shut down during the launch
Oh, we got a
countdown
picture of you and
sequence.
Judy there too. We'll show her
So, the other experiments.
yeah, here we were talking
there
about you and Judy.
Do I look like Judy Resnick? I think I got the hair part. That's about it.
You really look like Krista McCullough to me, in a way. But
Yeah.
no, I can see where people confuse you, of course. Yeah.
But so yeah, it was. I think it was just the long
From
dark
Akron,
hair.
Ohio, Judy Resnick there, and
Great
she-
Ohioans.
Yep, she was like I am, okay, but I like the Louisville area there. Yeah, 41. That was with our buddy Charlie Walker. Took the electrophoresis machine up there.
Hank Hartsfield.
Mike Mullane.
Yeah.
Yep. Hartsfield was the commander. Coates and Hawley went up there, in there. And no, we hear. And if Judy's real prominent in writing rockets, there, Mike Mullane's book there.
Yes, that's an excellent book. Yeah.
Yeah, almost got a chapter on her there. So we don't pass the day without looking at her on our memorial wall here, of course. So a couple of things. If y'all have a question, bring them on there. We were talking about the Astro telescopes being up there, and I have always asked the question, and Scott Vongen, actually, Scotty, I said, Scotty, why didn't they take these telescopes and put them on the International Space Station? Why isn't there a telescope on the International Space Station? And you probably know the answer to that.
Well, there's they have to reboost periodically. They have, as well as the fact that, you know, you probably know the answer better than I do.
Well, no, he said it's not stable enough.
It's, well,
believe it or not, it is like there's constant motion that can't be dampered out.
Expansion, contraction.
But also, like, this is a huge thing. And somebody literally jumps on one end and it resonates through the whole structure to the other end.
That's true. Well, I know.
And, so they can't they cannot stabilize the telescopes, they didn't think, as well.
Maybe a smaller one, but it's, you know, they've got, you know, some external payloads. They've had, you know, Earth observing cameras. I know in the, worked a lot with the internal experiments, and they had concerns because microgravity, you know, doing microgravity experiments, and, you know, the next rack over, they're doing something that's jostling that, and they would have some rack isolation systems to kind of dampen that down there, even within the, you know, the internal experiments.
Well, thank you. We're enjoying a conversation here with Maynette Smith. She's a level 4 electrical engineer. Okay. Things are flowing through things that she's dealing with there. And Marty's not here. We gave Marty the next couple of days off, and Matthew Raj is running our Streamlabs board here. Let's hear Matthew's voice on the USAC family microphone, as he's got another question from Michael Bruno. Matthew.
And Maynette, thank you so much for joining us and sharing all your wisdom and knowledge. Michael Bruno also asks, was it ever considered to place solar panels over the radiators on the payload bay doors?
That's a good question.
Yeah,
I have
that's-
never heard of that before. I would think that if you put them over the radiators, you're impacting the ability of
Dissipation of the
the
heat.
ability of the radiators to do
Yeah,
their job.
they're
So
radiating.
yeah, probably not. Um,
But you know, they
yeah,
never did consider putting it up and up and down in the payload bay to power the shuttle, where we power the X-37B mini shuttle spy plane with a solar panel. Apparently,
I didn't
yeah,
know that either.
yeah,
Um,
that's part of
well,
it.
and I think
They put one up like a mast
oh, and then it
and
sits
it's
there
off
in
to
a
the side or
okay.
something like that.
Yeah, but I think that might have been an opportunity, but at the same time, if they're flying other experiments,
Yeah.
is it impacting that? Um, and as well as, they're using the APUs, so it's a, different power system at the time. I don't know what it'd take to change that.
All right, thanks for your questions there. Let's look at another slide you brought here. This is so you were involved with TSS, huh?
Yes, for
So you got to know Andy Allen a little bit. He was the
actually,
pilot and commander.
yeah, I didn't get to
Yeah,
interact
he
with
doesn't
him
have
at
anything to
all.
do with the experiment. He
But
was the driver,
I
but
actually worked at up until actually when it finally arrived to KSC, and then I moved into another job. But I spent a good 4 or 5 years working the prep work for this, and it was
tell us what that is. I said
the
TSS is the
tethered satellite system. It flew twice, TSS-1 and TSS-1 reflight. And the tethered satellite, it was a joint NASA and Italian Space Agency activity. The Italians built the satellite. There was a number of experiments within the satellite. The tether itself and the deployer came from Martin Marietta at the time, before it was Lockheed Martin. And the deployer would, similar concept to the mast on the solar array experiment, where it would deploy out to a certain amount with the satellite sitting on it, and then they would reel the satellite out. The tether in this case, they made electrodynamic, so it was it was conductive, and they actually, as the satellite would move um, through space, it would pick up a negative charge, and it would go down the tether, and they would have some ion guns to bleed off the charge off the shuttle. But they had a lot of experiments because they wanted to measure the dynamics of the electrodynamics of this. It was a very complicated mission. A lot of different people involved with it. Um, I
and
ended up changing jobs after they arrived, but before they finished processing at KSC for the first mission. They flew the first mission. There was a late change where they had put a bolt in the deployer mechanism, and it wasn't able to deploy all the way. Got to be aware of those late engineering changes. And
yes,
so
a
they
mistake
actually
actually. Couldn't
they reflew as TSS-1R, and
what mission was that?
I want to say 46 was
Okay,
TSS-1.
46 consulting the scroll here. There we are. TSS 146 Shriver, Andy, Allen, Hoffman, Marsha Ivans, her second flight, Chang Diaz, Nicolier and Malherbe were the Italian
Yeah,
ESA
yeah.
astronauts there. And that was on Atlantis. And then they reflew it, and they got it out to that went out a mile or so, did it not?
There was, yeah, it was, I forgot how many kilometers it was, but they went out quite a ways. Of course, they got stuck the first time. They deployed it, I think it was deployed most of the way out the second time, and there was a flaw in the tether, and it ended up, the tether broke.
Yeah,
And it was like 20 they got like 20 seconds worth of data, but in that 20 seconds worth of data, they got a ton of information
Huh.
um, about all
That was STS 75 in
75.
96,
And
and the first one was in 92.
yeah, and but that was a thing that had been worked for years. And the whole concept of tethers is really great. But unfortunately, after TSS-1, and they did not fly another
Yeah.
tethered mission
And
on the
another
shuttle.
thing they've never done on the space station. The whole idea was to try to harvest energy,
Right.
right, as well as get plasma data and atmosphere
Or you could
reaction.
actually, even as something as basic as dropping down trash into the atmosphere, you know.
Yeah.
But yeah, so they've done a couple on, I think Delta had flew SEDS, which was a tethered experiment.
Tethered Satellite System, TSS, one of the great chapters of the shuttle where they were trying to uh, find some unknown things, and it didn't work out worthy enough to continue it.
Yeah, but like I said, they got a lot of great data out of it, even though it was
Mhm.
for a short period of time. But I spent several years working that in a capacity where I was integrating different engineering disciplines.
Okay. Well, then you went from an engineer to a manager.
Yes, and this is my first group that I was supervisor of. They were
Okay.
fantastic. I started out as chief of the partial payload checkout system section, and we checked out payloads like tethered satellite and Light, a leader in space technology, the U.S. microgravity payload series.
Very important to the
So
shuttle
yeah,
there, the
a
U.S.
lot of they
microgravity.
were
To what's going on the space shuttle, this was the groundwork for it
this
all.
a lot of this was a lot of the basis for what they see on the space station. And so this group was the folks that my first management position. They TP'd my office for my birthday.
Oh, I
Um,
see. That's what that
so
is.
you know, it's a whole different skill set when you go from engineer to manager, because you're being technical, and then all of a sudden you've got to rely more on, you're still technical, but you got to rely on those soft skills a lot more,
You know,
because
people
you're,
skills,
yeah, the people skills.
reading people and
Yeah.
understanding.
So it's a big transition, but it was one I'm glad I made.
How long were you a manager? To the end
Oh,
of your
for about
career?
20 years.
Yeah,
I went back
okay.
to engineering at the very end,
Uh-huh.
but was pretty much a manager for about 20 years.
And there we've got this is an example. Oh, this is a mission that I've always wanted to know about. Space Radar STS-59. Let me
Yeah.
consult the scroll here again and get our astronauts on that. Who is the commander of that? I thought, Gutierrez, Sid Gutierrez was the commander of that. And Chili Chilton, my birthmate, by the way, was the pilot on his second flight. Linda Godwin,
Oh yeah,
Jay
Linda.
Apt, Clifford, and Jones on that one, on Endeavour. So space, this was something that they discovered a lot of things they didn't know they would discover. But what's your pictures here?
So a little bit about Space Radar Lab. The first shuttle imaging radar that was of this series was called Survey. It flew one of the early, like STS 2 or 3, if I'm remembering correctly. And they flew different versions of this bigger and better imaging radar a number of times. And this was one of them, called Space Radar Lab. And we worked with them, worked out a thing saying, hey, wouldn't it be cool if we put some reflectors up on KSC, set them up so they spell out KSC, so when you fly overhead,
Oh,
you'll see us. Now it's hard to see in the picture, but if you see where the arrow is and look, just straight from there, it's KSC. So when they
okay.
flew the mission and flew overhead, these reflectors, which you see us setting up in the other pictures, were set up so that it would show KFC. So it was a fun little project to do for the mission.
And stretch the capabilities of this radar system that discovered things in the Sahara Desert, right? That we didn't know
Underground
still is.
riverbeds and
Yeah.
things, they were able to find out data so they could see, predict when malaria or outbreaks were going to occur. They've done some amazing stuff, and they flew a number of missions.
Yeah, I think Mike Baker commanded one of those. Because Bakes was talking about, yeah, as the second one he flew at Terry Wilcott, SCS-68. Because he talks about they had to put the shuttle in a configuration upside down, so to speak, with the payload bay open to the Earth.
Right.
All right, to do this,
To do
and
the
it was
imaging,
an
yeah.
entirely different maneuvering profile on there.
Yeah.
So, Jonathan Redman, did he work on the Tether with you? He says, "Yay, Tether program." Any advice on transitioning managers out there?
On
Jonathan.
transitioning to management,
Yeah.
or
I think that's what he means.
yeah, it's it takes about a year. I remember when I went to my boss after about 6 months, I'm like, I don't know if I can do this. I'm not near. If you know, you're working, the team is doing. I mean, you're always working in a team, but you're more dependent as a supervisor. Your performance is how your team is performing, and I had a high performing team, but I kind of felt I was superfluous, and went and talked to my boss, and he goes, it takes about a year to make that transition where you've got that mindset where you see what you're doing. And he goes, give it another 6 months. And if you haven't made the adjustment, we'll put you back in engineering. But by then I had made that transition.
But I know who that boss was.
John Conway.
John Conway. I've heard that name.
Yeah, he was the director of payloads.
Yeah.
And
not met him, but
no, he's a great guy. You ought to have him on.
He's still around?
Yeah. Yeah,
part of the Rocket Ranch reunion group?
I think he comes out there.
All right, yeah.
He's also
We'd
in
love to
the
talk to
Alumni
him
League
there.
as well, NASA Alumni League.
We're enjoying this conversation with Maynette Smith. She's supports all of the retiree type things going on around here, and we hope she and some of her friends are interested in volunteering a few hours a week here at the American Space Museum, right there in our beautiful. We're right there at the tip, right there, Maynette. That's one of the more beautiful shots of our peninsula here. We got Doug Forrest is saying hello from. He's in Los Angeles. There, drives by where Endeavor is.
Oh, nice.
I want to go out and see Endeavor.
I want to see
How
that
about
too.
you?
Yeah.
Yeah. Have you seen Discovery in Washington?
No, I haven't. I want to go to Varhazy Museum too and see that.
It's amazing. A privilege to be there a couple summers ago. Let's see what we got here on the home stretch with Maynette, the International Space Station utilization.
So after I moved into management and was working the shuttle side of the house, I moved over to what they call ISS utilization, which is the experiment or science side of the house for space station. And space station was very different because, you had some parts on orbit. You had to simulate the ones on the ground so you could test what you had on the ground. The experiments, would go into racks. We would fly the racks up, but the racks had never seen the lab it was in, so we had to simulate all that. So it was really a very interesting, exciting time because I came over before we'd actually processed. So we were building the capability. And so I got to be there as we processed through a number of the first missions, including the human research facility. We had some express racks that we processed that had some smaller experiments in them, and some of they called them facility racks. The human research facility and, for example, the microgravity science glove box were two examples of ones that were dedicated for a particular type of science discipline, and they had experiments that they did within those facilities, like different microgravity experiments for the microgravity science glove box. So I worked in that group for a number of years. I spent a couple years after that working on the fourth floor with Mr. Jim Kennedy and Dr. Woodrow Whitlow, working strategic planning. Came back to my space station.
Fourth floor is the
fourth
office is
yeah,
there. That's
it doesn't exist anymore because the headquarters building it's the old headquarters building is gone. It's now the 7th floor, but worked got the opportunity to look at how KSC operates from a different perspective, and then came back to space station for a while, and then and we can move forward.
Well, we've got here AC Tobias Black says, so amazing to see this. I'm studying to be an EE one day, electrical engineer, but that's on hold. So amazing to see and hear these insights. And
Aw.
we've got Mostly Park says, nice conversations. Thanks to all. And that's what we do here every day of the week from Monday through Fridays. Have a conversation about space. Sometimes I have it with myself, but and all of you out there. But it's great to have Maynette here. Maynette, we've not talked too much beforehand, so I think I'm on the right track here of what you're going to tell me. Something very interesting. You just don't get out of your car and walk in and open a door and go into the space shuttle processing facility.
No.
Well, what is that process like from your car to where you're sitting and doing your job?
Well, as
You go
part
through some different barriers, is what I'm
yes,
trying to
oh
say
yeah,
there.
there's
Cleanliness is
yeah, there's
godliness.
oh yes, well there and before you even get that far, you're go through some training classes and you're getting some certifications and all that. But if for example I was going to go work on a payload, I would be going in and to a clean work area. And once I'm with so close to a payload, depending upon the requirements, I would be getting in a bunny suit or getting in a smock and cap, um, wearing gloves, the appropriate gloves for. Sometimes you had more uh, complex controls, like for example, tethered satellite. The satellite was very sensitive to magnetic fields, so you had to degauss your equipment before you actually got within range of it.
Degaussing means.
You wanted to make sure that it was you had any extraneous mechanical or
Hmm.
magnetic fields
Hmm.
or neutralized, and because you didn't want to mess up, you know,
Did you walk
their
on
hair.
sticky paper for your
Oh yeah,
feet
you had
then?
to clean your feet. A lot of times you had booties if you were working up above a certain level. So it depended on what level you were working at, how close you were working at. Um, and of course the guys, you got a beard, you got to wear your mask. Uh, some, for example, we had some payloads that had very higher cleanliness requirements. So they had even, if they were like 10K versus 100K clean room area, they had to take additional
What does that mean?
steps.
10K to what's the
That's the
K?
parts per million
Okay.
that they allow of particulate.
Yeah. I've heard you
And
go can even go through an air barrier
yes, yeah, they have
or
some
or
air showers,
air showers what I'm
and
saying there.
so it
Yeah,
just
and I
depends.
bring that up because, this is you're just not going in and sitting down on your computer and turning everything on. You got sometimes to go through some of this elaborate equipment, personal protection equipment, and other things before you can even start working.
Yeah, when
And
you're
some of
in
that stuff's kind of
proximity.
hot, it strikes me as too.
Yeah, it can get a little warm.
Uh-huh. All
It
right.
can get a little
I
warm.
remember several jobs I had to wear gloves and something, and my fingers sweat a lot in those gloves.
Well, and then you get the folks that are working, if they're working with hypergols, they wear scape suits.
Oh yes,
So,
yeah.
then that's a whole
That's a whole
another
other
level
level when you're
of
dealing with the
yeah,
fuel and so forth
yeah,
in there. Great. I was just trying to humanize this a little bit because, like we said, this is your friends and family members maybe that have worked on the shuttle or even Apollo, and you don't see what goes, behind the big buildings out there at Kennedy Space
that's
Center.
true.
So, thank you for sharing that. All right, we're almost on the home stretch here. Two things I've always wondered about is safety and mission assurance. And the word assurance, you are assuring something is going to be right. So tell
Yes.
us about your journey with that,
Yeah. So
Maynette.
probably the last, oh gosh, 8 or so years, I was in the Safety and Mission Assurance Directorate. I had worked on the operations side of the house for many years and then moved over to the Safety and Mission Assurance side. So now we're the folks being the second set of eyes on the ops folks, if you will. And it's knowing the operations side, it was helpful, but I learned so much from my time in safety and mission assurance, because you've got your safety folks, you've got safety engineers, you've got safety specialists that are down on the floor. The safety engineers are doing analysis. You've got quality engineers and quality assurance folks. And all those folks, most of them come from different backgrounds, military or other backgrounds. They've worked on aircraft, they've worked on a lot of different things, and they carry such an amazing amount of experience with them. And here they come, and they're the second set of eyes. Are you doing this, mating this connector correctly? Let's make sure you're doing that. Or from a safety standpoint, do you have all your safety controls in place? So it was a very interesting journey with them. It was I learned so much, and as we moved toward more of a commercial, with SpaceX coming in and all that, the safety model kind of changed for them versus the traditional government oversight.
Mhm.
So I was there for part of that, trying to address that and make sure that we were addressing that correctly.
Not, frankly, it's sort of been eliminated in the private companies, has it not? The assurance, the extra set of eyes on
No,
things. Or,
for example,
tell us about that.
the commercial crew program, one of the biggest things they had to figure out was the level of penetration by quality and safety. It's maybe not as deep as traditionally what we have done, but it's still there.
Okay.
Because our
Obviously,
astronauts are flying
SpaceX
on there.
Yeah,
So we want to make
SpaceX's
sure
record has been exemplary, of course, not just with the unmanned Falcon 9, but the crewed ones as well. What are these pictures here? Who are you there with in the
Oh,
middle there?
So that is Robonaut.
Robonaut.
Robonaut flew on the International Space Station, and he was being processed down in the space station processing facility, and we had an opportunity to get our
Okay.
picture with him. But he actually was in, I think, the U.S. lab, and was there to kind of be an extra set of arms. For it was a test to see,
Hmm.
how much robotics can help.
And how did that work out?
I think it worked out well. They
Yeah.
went through some iterations with it. I don't think it's up there anymore.
Dexter also was a little outside mechanical arm thing, looked
Yeah,
like a
that
stick
was
figure man.
um,
And I don't see that they utilized Dexter or the Robonaut like they were going to be like an extra crewmate to do maintenance.
well, I
Even.
know Dexter. You're talking the Canadian arm.
Yeah,
Yeah,
yeah.
and it has been used.
Mhm.
I don't think you see it as much as like you saw its use on Shuttle, just because you don't see that amount of coverage. But
Well, how you feel about robotics and needing people in the space
I
station or future
I
space stations?
I think the space station is very crew intensive. Not only just maintaining the station itself, but then trying to do your experiment work on top of it.
Yeah.
So if you've got some things that you can automate some um,
Okay.
safely, then I think it's a good thing.
Maintenance is huge. It spends a lot of astronauts' time. Or were you
Yes.
obviously you had to be part of that maintenance routine and the training part and mission when you lay out the mission directives and so
Well,
forth.
one of the biggest challenges, particularly for space station utilization for the experiments, is the what they were building the station at the same time, which made it really hard to get the experiment work done. And a lot
Uh-huh.
of astronauts would they loved doing it, so they would do it on their off time too, if they had off time. But now that they're fully built, the station's fully built, and they've, I think, pretty much got it down time wise. But of course, as station ages, you've got more time to maintenance, so it's a balance.
Yeah, well, there's constant maintenance, just like our maintenance guy Dan here shows up the first every month to change out the filters in our little system here. This is things that need to be done all the
Yeah,
time.
always.
What are these pictures of your? What's the upper left hand picture?
The upper left hand picture is one of our quality assurance folks. It's Linda Burns, was working doing some receiving inspection of some flight hardware.
Hmm.
Um,
And the pictures of all the beautiful space workers there.
that was kind of just showing what a team it is to do this kind of work. The bottom left, that is the whole group of folks that worked International Space Station here at the Kennedy Space Center. And the one on the bottom right is my team that I worked with, is the Space Station Safety and Mission Assurance Division. So, and of course, then the picture up above is STS-135, the last shuttle mission, and my role as a Safety and Mission Assurance Division Chief in the firing room too.
What was that like? The end 14 years ago.
It was really bittersweet. I still, there's so much capability in the shuttle. The ability to, just for example, to process, you have life science experiments on the station, and then be able to bring them down and immediately pull them off before they adapted to a 1G environment was huge. I think shuttle, was going through at one point, midlife recertification before, Constellation came and all that. So she probably had a lot of years left in her, had a lot of capability, but understand why it was time to move on.
Yeah.
But they up until the last flight, they were still learning new things about her.
Oh my gosh, they say Atlantis was so clean, and Endeavour and after their final missions, Discovery, they were just hitting their stride, and the workforce was in their groove. And I mean, that's what we hear a lot from you workers there. But then again, it was a cumbersome, technologically behind vehicle in some regards. They keep having to upgrade.
Well, yeah, but at the same time, it's really the first of its kind.
Oh,
and
absolutely.
and just
Yeah.
Never
will be another one, maybe.
no, and it's
Astronaut Blaha, John Blaha says, I think it'll be 100 years before anything like this is ever built again. It was so.
No, it's so complex,
Yeah.
and we're still learning the dynamics of it.
Well, we've got
Yeah.
people almost 15 years later still very interested in it and learning about it, including
great.
Tom Celentano there, who said that we've had an interesting show here. Thank you, Tom, for watching, and Maynette being here. We've got a good slide here of the future.
Well, this was, the question was, what are we doing, in the future? And I know some of that is a little bit in flux, but, it kind of boils down to, we're going to commercialize low Earth orbit. We're currently doing that now. And of course, returning to the moon, which I'm really thrilled about. And then, of course, maintain and transition the International Space Station to whatever comes next.
What do you stay in touch with people working out there? Is there any vibe about when we are going to deorbit the ISS?
Don't really have any idea. I think deorbiting's a huge deal for something as big as this.
It is. I've learned that from Mr. Bob Cabana, actually educated me a little about that.
And so, I could envision, this is just me talking, that, they could transition this to a commercial entity if they wanted to operate and maintain it. To me that seems like a logical thing to do. And not deorbit. I mean, I still remember when they deorbited Skylab, so that was quite interesting.
Now, we'll do a show on that. There are some, of course, the 25-year segments of Zvezda, Zarya, and Unity there, were the core. Kibo's still a fresh observatory, and I thought, like, why can't I asked Bob Cabana, the great astronaut and director, I go, why can't they just take Kibo off of there and preserve it somehow? He said, too complicated, too dangerous. Probably it would take people to twist bolts and stuff like that on there. This ammonia that is the coolant up there is very nasty stuff. Ammonia is a big deal up there for the coolant of all the radiation, radiators, stuff like that.
Well, it's so integrated now. Really, it's hard to just take apart.
And what Bob Cabana told me is they're going to have to put it in a certain profile to put it in the Indian Ocean. All of the solar panels are going to have to be in a certain way. And he said that there might be a crew on there within hours on dock, just an orbit or two before they give the word to go in there. It really needs some manual
Yeah, it
guidance
can't
to,
be automated.
yeah.
Yeah.
Yeah, so
Wow.
we'll wait to see that. I don't want to see it, but um, probably be selling tickets over the Indian Ocean when it happens to see it come down there. So
I'm hoping that they decide to transition it somehow and it stays up there for a while.
yeah, as long as we can keep humans safe on it, why
Amen.
not there? So where's Maynette's thank you question slide there? I guess it didn't show up there. Any questions for everybody out there? You've asked quite a few there. We're going to have a dinner with Bob Seek there, but let's put Maynette and I back up there on there. I've enjoyed talking to you and learning so much about this. We've got Dave Stange, RG Jubilee, Tom Usiak, Elena Adkahara. Why don't you give a shout out to the rest of them?
Oh,
there?
let's see. Hopefully I don't massacre any names. Thomas Celentano,
Up in Connecticut.
Carlton Braley,
Bailey, he's the photographer.
Bailey,
Yeah, you know
Bailey. Oh, so,
Carlton.
okay, yeah.
He's out there at Canaveral Groves at his wildlife
Yeah.
preserve there
And Dean Babcock,
Yeah.
Cliff Watson.
in Australia.
Hi, Cliff. Michael Bruno,
Michael's in Miami.
Jonathan Redmond, Doug Forrest, Octavius Black,
Yeah,
Goddess Kratos, mostly parked.
yeah, mostly.
Part. Yeah, so
Well, thank you all
Thank
for
you.
watching today. Hope you learned something that you didn't know about. That's always our goal, is to keep alive the shuttle era, as well as celebrate the Apollo era that built our museum. Maynette, thank you so much for
my
taking your time to
pleasure.
do this.
I wish some of the really hard questions there, I wish I could have answered them.
No, you answered them to the best of your ability, and definitely everybody, even like Mike Leinbach, the great launch director and manager. You can't know everything about every system and everything going on. This is why NASA is so amazing. They created a culture where you have to trust the person behind you. You know, up all the higher up you go, the more those high ups are trusting the
Yeah.
people behind them
Takes a
that
team.
that everything they're doing is true and safe and going to assure that the mission is going to be a success. So
Amen.
we know you've got a lot of friends watching out there, and we welcome some of them to come on our Stay Curious podcast and share your journey with America's great space program. So, Raj, thank you for running a great Streamlabs here today. We're going to do it again tomorrow without Marty. We're going to look at some. I like looking at current events and news going on, and on a Friday, getting people excited about the weekend. So, and we got Shank Thomas up there. He says thank you from the 321. All right, Shank. Appreciate you watching us today. As all of you, tell people to share, follow, like, whatever. Go to our Facebook page, and you can donate to our GoFundMe to help us recover some of the costs of our fire that was here in our kitchen. It was just an accident that happened, but no artifacts damaged, but some smoke damage, mostly in our space shuttle gallery though. So appreciate everybody helping with that. So thank you all. I'm Mark Marquette, and I appreciate everybody enjoying our program and sharing it with others, as we are all about preserving the birth of the American space age right here where it all started, Brevard County, Florida. Until next time, I hope to see you to bridge the space between